Hello and welcome to this On Semiconductor webcast. Today we'll discuss a power integrated module for a T-type inverter used in solar inverters and UPS applications. Traditionally, the power stage of a solar inverter has been built from discrete high-side and low-side IGBTs or power MOSFETs, and the gate of each device is controlled by a separate gate driving IC that can tolerate being connected between the low-voltage logic controller and the high-voltage power transistor circuitry. A fast recovery reverse parallel diode might be connected between MOSFET drain and source pins, or IGBT collector and emitter pins, and a number of passive components are needed to complete the circuit. Designers are under pressure to reduce the cost and size of these assemblies and are responding by using various techniques such as building integrated mechatronic modules that combine the power electronics with the motor in the same assembly. This places tight size constraints on the design. At the same time, meeting EMC standards requires noise, such as internally generated switching noise, to be properly managed. To help satisfy these requirements, power integrated modules or PIMs have emerged, which combine the power transistors, gate driver ICs, protection circuitry, and other components in the same package. These modules not only save space and reduce component count and bill of materials cost, but also simplify design and so reduce the system manufacturer's reliance on specialist power electronics design skills. The system producer can also get new designs to market quickly, and reliability is improved since the number of electrical connections is reduced. Designers of such systems, such as solar inverters, UPS, and small industrial drives, are constantly pushing to produce more compact and reliable assemblies at lower cost and within shorter project timeframes, while meeting high targets for performance and electromagnetic compatibility. Equipment such as solar inverters, domestic appliances, air conditioners, and industrial drives are known to consume a high proportion of the electricity generated globally. Inverterized motor drives are becoming more widely used to enhance efficiency and reduce overall energy consumption by the world's electric motors. In addition, electrically actuated mechanisms such as power steering and coolant pumps, as well as various other pumps and fans, are becoming increasingly prevalent in automotive applications. The use of solar or wind generation, including small microgenerators, is another emerging sector driving demand for rugged and high-efficient inverters. This webcast will specifically focus on solar inverter and UPS solutions using a power integrated module or PIM in the Q0PACK packaging. One benefit of using an I-type or T-type topology is the lower output voltage distortion that reduces the filtering effort in semiconductor device stressing. The I-type can be equipped with semiconductor devices having breakdown voltages of half the DC link voltage only. Therefore, switching losses are less affected by the switching frequency. Due to its low conduction losses, the T-type inverter shows higher efficiencies at lower switching frequencies due to its rather acceptable switching losses. The strong switching frequency dependence, however, is a major drawback of the T-type inverter due to the implementation of 1200 volt SI IGBT switching devices, as they have to withstand the whole DC link voltage. Regardless, the T-type topology brings great trade-offs between performance, complexity, and cost, as the advantages and disadvantages list indicates. The Q0PACK PIM incorporates all the semiconductors needed for the neutral point clamped T-type inverter. These include two sets of IGBTs and rectifiers rated at 80 amps, 1200 volts for the half-bridge segment of the topology, and two sets of IGBTs and rectifiers rated at 50 amps, 600 volts for the neutral point segment of the topology. The IGBTs in the module are designed using ON Semiconductor's Trench Field Stop 2 technology that allows judicious optimization of the circuit performance by trading off low VCE against low E off. The IGBTs also feature maximum theta J equal to 175 degrees C or short circuit capability. The ultrafast rectifiers used in the Q0PACK modules offer low VF performance and high temperature compatibility. Finally, the Q0PACK module employs direct bond copper or DVC technology that enables high current operation with minimal parasitic inductances. The resultant impact of these innovative design features is a high efficiency system performance, as you'll see next. The performance improvement offered by the Q0PACK modules was tested in an end application where the thermal and efficiency performance was benchmarked against a similar competitor's module. Semiconductor has a fully equipped systems application lab that houses the evaluation platforms and all the required measurement equipment and data analysis tools for such benchmarking. The Q0PACK was evaluated in a 7 kilowatt T-type inverter application running at 15 kilohertz, operating at a line voltage of 200 volts AC and with a DC link voltage of 600 volts DC. The basic topology used for test is shown in this slide, together with a photo of the experimental setup. The experimental application includes all the needed operations and captures and analyzes waveforms, power breakdown data, efficiency, and temperature measurements. The T-type topology enables 4-quadrant operations, so our recuperation concept makes it possible to optimize our modules for any condition. The efficiency and case temperature were measured at different load conditions. The resulting improvements in temperature ranges from about 2 degrees C at 25% load to above 4 degrees C at full load. The efficiency improvement was shown to be 0.1% at full load. The improvements can be attributed to better device design and also to a better packaging solution offered by the Q0PACK module. The application evaluation for our high-demand products need many types of measurements. As an example, we can measure temperature, efficiency, and power breakdown. In addition, these measurements must be done for many operating points so that our final product fulfills all requirements. The right-hand picture exemplifies 4 cases for many conditions. This is very challenging to do by hand and with a real application, which is the reason why we developed our own testing interface to do all the tests automatically. This interface connects many meters into a single point, and the important feature is the collection of data from all the needed equipment, which sets up the parameters for the application. A final advantage to mention is the remote operation, which makes our environment safer. One of the most important pieces of information which can be obtained from real applications is energy loss distribution. It is possible to get exact information about particular energy losses produced during switching dynamics in a concrete semiconductor device. In modern topologies such as T-type, the losses are not symmetrical, which brings up a great opportunity to optimize die sizes to get maximum efficiency and flatness of the efficiency curve. We can get so-called power breakdown data referring to the switching or line period. The first step in getting this information is by obtaining a VCE and IC measurement by the help of the appropriate voltage and current probes to capture the waveforms by the help of a digital scope. The last step is the most difficult. We're using modern software for creating algorithms for fast and exact power loss recognition and distribution, as can be seen in the chart above. As shown in this short presentation, Semiconductor has shown a strong performance improvement with its new Q0PACK PIM module. With in-house capabilities that include continuously improved silicon design, innovative packaging design, and world-class manufacturing and logistics space, Semiconductor is uniquely positioned to service the needs of its industrial customer base with an ever-expanding portfolio of high-power, discrete, and modular solutions. If you have any questions on this or any other PIM modules, please visit us at www.onsemi.com or contact a local distributor or salesperson to discuss your specific requirements. Thanks so much.